Midway Tower, Aircoup 99055, Mayday, Mayday, Mayday. Aircoup, Midway, go ahead.
Hi guys, today I will try to tell you about an extraordinary aircraft. Introducing the B-2 Spirit Strategic Nuclear Heavy Bomber, the most expensive aircraft of all time in the world. The fact that this legendary aircraft, which was started to be built by Northrop Grumman in the United States and spent billions of dollars for its development, was not sold to any country, including its closest allies, shows how important it is for the USA. Before we move on to the technical specifications of the aircraft, we first need to open a parenthesis about the price. When we take a look at the prices of similar aircraft in the aircrafts category, even the fully equipped prices of these aircrafts you see are not even close to the B-2 Spirit. Now hold on tight, the price of B-2 Spirit is $737 million per unit, which is even more expensive than the $660 million Air Force One plane designed for the high-level security of the US presidents. In fact, if we factor in the total program cost, which includes development, engineering, and testing, in 1997 it averaged $2.1 billion per B-2. So why is this unique plane with a high cost so expensive? Let's take a look at it. In fact, it can be thought that the high cost of the B-2 project is a result of the development expenditures made over the years in order to develop the invisibility technology feature in order to overcome the Soviet air defense systems in the 80s. However, the biggest factor in the increase in the cost was the decrease of the 132 units B-2 ordered by the US government at the beginning of the project to 21 units after the disintegration of the Soviet Union and the end of the Cold War. This situation caused the unit cost of the aircraft to increase excessively. With the emergence of the plane and starting to fly, the fact that keeping the plane ready for flight has a high bill in addition to its costs has emerged. In other words, each flight hour of the B-2 costs $139,000 and 119 hours of maintenance were required for each flight hour. They also had to be stored in specially air-conditioned hangars to protect their special low-visibility graphite/epoxy coatings. This meant a monthly expenditure of $3.4 million for each aircraft. In the light of this cost information, it has been calculated that an incredible expenditure of approximately $64 billion has been spent until 2021 for the B-2 fleet of 20 aircraft, which is planned to be flown until 2032. If we go back to the historical development of the aircraft, the B-2 Spirit first met the sky in 1989 with the completion of the design stages and started to be delivered to the US Air Force in 1993. This project, which was given great importance in the beginning, lost its importance in the following years, and as an experimental aircraft, it gave direction to the aircraft that will come after it. Operationally, Serbia, Afghanistan and Iraq also carried out bombardment missions. B-2 aircraft are still in service with the US Air Force. These aircraft are planned to be replaced by the new generation of unmanned B-21 bombers in the near future. In fact, there have been many developments in aviation in the period after the aircraft became operational, and smaller, faster, thermal traces and less costly aircraft have emerged that cannot be detected by the radar. These positive developments make the B-2S even more controversial. Now we can move on to the technical specifications of the aircraft. For F-118 GE-100 turbofan engines are used in the B-2 bomber. These engines in the B-2 are models that do not have afterburner, that is, afterburner, used in many aircraft, including the F-16. For this reason, B-2S can move at a speed of about 1,000 km per hour and cannot exceed the speed of sound. The lack of an afterburner system is purely to provide infrared stealth and invisibility. There are V-shaped exhausts on the rear upper surface of the aircraft to hide the exhaust heat of the engines. Carbon fiber reinforced polymer and titanium alloy elements placed at the base of the engine exhaust outlets prevent the exhaust heat from affecting the underside of the aircraft. This is because the enemy's infrared sensors will often scan the bottom of the aircraft, thus greatly reducing the infrared view. The engines are placed inside the fuselage for the purpose of preventing the position of the aircraft from being understood by its sound and for sound insulation. Atmospheric air taken from the ducts under the front air intake and the exhaust gases of the engine are mixed together, and the resulting gases are cooled to a degree that cannot be caught by infrared cameras. If we look at the internal structural features of the engine, the single-stage HP turbine drives the 9-stage HP compressor, while the 2-stage loop turbine drives the 3-stage fan. As is known, engines with high gas outlet temperatures can be detected by air defense systems or thermal cameras and can make the aircraft an easy target. In this sense, we can see the B-2's F-118 engines as 5th-generation engines. Since the exhaust vapor traces of the aircraft can cause visual detection of the aircraft at high altitudes, chlorofluorosulfonic acid is injected into the exhaust gases of the B-2 to prevent this. Materials known as graphite epoxy are used in the hull coating of the aircraft. These materials absorb the electromagnetic waves emitted by the radars and convert them into heat. These coating materials supply the B-2 look like a big bird on radar. In this sense, B-2s are one of the aircraft with the lowest radar cross-section in the world. The 35-degree angle of the wing leading edges and the 215-degree W structure of the trailing edge are designed to deflect radar electromagnetic waves. One of the most striking aspects of the aircraft is it has not vertical stabilizer in terms of reducing radar tracks. The yaw movement of the aircraft, that is, the movement of the aircraft to the right and left in the horizontal plane, is made by the split rudder control located on the wing tips. These controls work with the pedal movement of the pilot. If the aircraft is under intense radar threat, it can change direction without leaning by increasing the thrust of the engines in the opposite direction of the side it wants to turn when it wants to turn right and left, that is, yaw movement. This is called differential thrust. Split rudders also act as air brakes on landing. Direction change movements such as roll and pitch given by the aircraft's lever are made by the control flaps called outboard elevon located behind the wing. On the other hand, inboard or mid-elevon flaps are used as secondary control for steering the aircraft at low speeds. The moving part, known as the gust load alleviation system, located in the middle of the aircraft exhaust outlets, is used to lighten the wind loads acting on the aircraft by moving up and down, just like birds use their tails in nature. All the flight control flaps we mentioned here are directed by the flight control computer in addition to the pilot's control so that the aircraft can work in coordination due to the structural instability. The capacity of the aircraft to carry approximately 18 tons of ammunition in terms of weapon load puts it in the heavy bomber class. Perhaps the most important of these munitions are the nuclear bombs known as B-61, B-83, and Mk-84. The range of the B-2 is 11,100 kilometers. In other words, a plane taking off from the U.S. state of Missouri, which is the base of the B-2s, can reach the easternmost part of Europe without refueling. There is no point in the world that it cannot reach with air refueling. However, with the news that tests are being carried out for the F-35s to gain the ability to drop B-61 type nuclear bombs, it seems like the end of the road has been reached for the B-2s. Because although the F-35s are not bombers, they will seem to dethrone many planes due to low production and operating costs, multifunctional operation diversity. For this reason, it is foreseen that the B-2 will be removed from service very soon. If we talk about the other disadvantages of the B-2s, it has a bulky structure and cannot reach supersonic speeds, which makes it an easy target if detected. Although it has its own special defense systems, imagine that this plane was shot down while carrying 18 tons of ammunition and nuclear bombs. It is very clear that this will cause disasters for both the USA and the country that hit it, and the world. In addition, air defense and radar technologies, which are developing every day, can enable aircraft that are thought to be invisible to be seen. We should also talk about ballistic missile systems in parallel with this issue. In recent years, with the production of intercontinental missiles with incredible speeds of 14 times higher than sound, is questioned the existence of aircraft such as the B-2. By the way, I would like to talk about an interesting detail. A person who was browsing the internet on Google Earth in the past months took a picture of the B-2 while flying in the air by chance. This situation made the invisibility of the B-2s even more questionable. It will likely be drones that will dethrone the B-2 and similar expensive aircraft. Unmanned aerial vehicles, which can perform all the tasks that B-2s can do, with much less cost, without risking the pilot's life and invisibly, have begun to be accepted as the most preferred aircraft in the world. Today, the process of unmanned aerial vehicles, which started for reconnaissance purposes, has evolved into direct bombardment missions with point terrorist operations. The days when we will soon start to see unmanned aerial vehicles with artificial intelligence that make dogfights in the air are coming soon. Thank you very much for listening to me. Hope to meet you in our new videos. Don't forget to subscribe to my channel and like my video.